It's a first stage of rocket. Each rocket stage has fuel and oxidizer tanks, or one fuel tank if liquid fuel is used. If the rocket uses an oxidizer, hydrogen reacts with oxygen, for example, creating an explosion that escapes the engine. The fuel burns quickly, but a huge amount of gases escapes through the engines. There are so many gases that the rocket flies up. The hot gases push the rocket upwards. After reaching the appropriate altitude, the rocket disconnects the first stage. The second stage is most often similar to the first stage, only it uses weaker engines to exit the atmosphere. If the flight plan involves returning to the Earth, re-enter, the capsule with the protective shield breaks free and falls into the atmosphere. Heating up to enormous temperatures at low altitude, the parachute releases and the capsule lands on the ground. The shuttles were made of ceramics so they wouldn't burn. The shuttles entered the atmosphere at a huge speed, several times the speed of sound. In this science, there are things such as the thrust force and the weight of the rocket. The thrust force must be higher than the weight. If the thrust force is large and the rocket weighs little, it may fall apart because the elements will not be able to withstand such a speed. But if the thrust force is too low, the rocket will not take off. The third stage of the rocket usually contains a small engine that allows you to work a lot without any problems. With a large fuel supply, this engine is the goal for success. But you need to remember about the thrust force. The third stage was used to approximate the flight trajectory to the moon. Then there is the lander. It contains a small engine and medium fuel supply. It also has legs for landing and, of course, there is a capsule. It contains a parachute and a place for astronauts, where they control the entire flight of the rocket. When the lander approaches the moon, the engine turns on and brakes the lander, and some landers have panels for collecting solar energy.